Question number 5. We're asked to evaluate the function at the given value and then simplify. So before I jump into this one here, what would you do if I asked you to find f of 3? Well, we'd go over to the function f of x, and wherever we see an x, we would plug in a 3. So we have 3 squared minus 4. And then we do whatever is necessary to simplify. So get 9 minus 4, which will equal 5. So we're going to do the same thing here, except for in place of 3, we're going to plug in now x plus 3. Okay, so we're going to do the same thing for this one. So f of x plus 3, I'm going to go up to my function f of x, and wherever I see an x, I'm going to plug in x plus 3. So I have x plus 3 squared minus 4. Now this has to be simplified. If you know the formula for x plus 3 squared, you can go ahead and use it. If not, make sure that you FOIL it out. So you have x plus 3 times x plus 3. So we'll have x squared plus 3x plus 9 minus 4. Now combining my like terms, I'll have x squared plus 6x, and then 9 minus 4 will give me plus 5. And so this is what f of x plus 3 is equal to. You want to stop right here. Question number 11, they asked me to identify the intervals where the function is increasing. And I'm going to go ahead and work through this for, increasing, decreasing, and constant. First, I'd ask you to recall what it means by a function is increasing. We are asking you for which values of x are the y values getting larger. So for which x are y values getting bigger? Are they increasing? Okay, and so graphically that means when you're moving from left to right, you're going uphill. For decreasing, as you move from left to right, your y values are getting smaller. They're going downhill. And if we want to know where it is constant, it's where the y values remain the same. So again, moving left to right, you have a horizontal line. The y value stays the same. Okay, so over here, where is my function increasing? Well, notice that, right here, I'm just going to trace along my function, so I'm coming in here like this. So that's constant. Then I'm going downhill. That's decreasing. Then I'm going uphill. That's where it's going to be increasing. And then I'm going across. So that's going to be constant. So right here is where it is increasing. So what are those x values? So it looks like it's going to be from -2 to +2. So increasing on the interval from -2 to +2. Now where was it decreasing? So let's see it decreasing. So where was it going downhill? So it was going downhill here, and that's it. So what are those x values? That's just between here and here. So -3 to -2. And then lastly, we can go ahead and look at where it is constant. So it'll be constant whenever the y value is the same. You have that horizontal line. So it's constant here and here. So again, what are the x values? So it looks like -infinity to -3, and then again from 2 to infinity. So the one word of caution is, when you're looking at the graph, remember that you are giving the intervals for x, not for y. For number 14, we're asked to use the graph of the given function to find any relative maximum or minimum. Okay, so we're looking for maximum and minimum function values. The definition, so for a maximum, it means that it has to be the largest y value in some small area. And so if you're looking at a graph, that's usually going to be, the top of some hill. And then when you're looking for the relative minimum, okay, relative, so in some little neighborhood, it's the smallest y value. So again, that would be like the bottom of some valleys. So this is where you would have a relative minimum, and somewhere up here on the top, you would have a relative maximum. So those are the points we're looking for. So on our graph here, we can pretty much see that it looks like I have a top of my hill right here. Like I said, if I'm just looking at this little neighborhood, you know, that's the greatest y value. So I'm going to have a maximum, a relative max right there. And then also down here, notice I have a point that's lower than all the others in that neighborhood, not over the entire graph, but just in this little area. And so that's going to go ahead and give me a relative minimum. So what are those points? So, okay, I have a relative maximum at, what's the x value? So it's at x equals a -2. And the relative maximum function value is going to be the y value. So that's at y is equal to, right here, the y is 18. Notice that our graph is counting by 4s. Okay, so now for the relative minimum. I'm going to have a relative minimum, that's this point down here. So that looks at x is equal to a 2. And then my y value, so the relative minimum function value is going to be y equals, that's a -14. So it is important to kind of distinguish between the x and the y coordinate of where these occur. So like I said, just think of it, it occurs at the x value because that's your independent variable. And then that, you know, your function value is going to be the y value. Sometimes these are given to you as ordered pairs. So again, I could write it as -2, 18. And then this ordered pair is 2, -14. Number 18, we're asked to evaluate the piecewise function at the given value. Okay, so piecewise defined functions. Remember that when you're working with a piecewise defined function, you have your real number line. This is for, you know, all real numbers. Okay, and notice that for this particular example here, it's going to change at -1. And so for any x, you know, when x is less than a -1, so from here to here, I'm going to have the function f of x equals 3x plus 4. And for any function value where x is greater than or equal to 1, so if x is greater than or equal to a -1, so this part of the real number line, then my y value, or my function f of x, is defined to be 2x minus 4. So it is the x values. This determines which one to use, which function to use, which piece to use. So it decides where to go. All right, so let's go ahead and work on a couple of these. We're going to go ahead and find, f of -5. I want to find f of 3, and then we'll also find f of 1. Okay. So f of -5. In this case here, x is a -5. So x is a -5. Where is that going to be? Yeah, it's down here. It's, it's over on this side right over here. So that means I'm going to use the function 3x plus 4. So I'm going to have 3 times a -5 plus 4. And this will give me -15 plus 4, so -11. For f of 3, and this is the one we were asked for on the test, on the practice test, where does x equal 3 fall? So x equals 3 is going to be over here. So I'm using the function 2x minus 4. So 2x minus 4. And so 2 times 3 minus 4, we'll get 6 minus 4, which is a 2. And then what happens if I go with x equals a -1? I'm going to go ahead and use -1 because that's where it splits. So which one of these two should I use? Well, that's right here at the split point. So which one has the or equal to? It's the bottom one. So there's going to be 2 times my -1 minus 4. So -2 minus 4, which will give us a -6. Okay. So like I said, just kind of remember piecewise defined functions. Look at the x's. So if x is less than -1, greater than a -1, that will determine which function to use. Number 22, find and simplify the difference quotient. Okay, now the difference quotient, this is the formula right here. This formula does not change. That is the difference quotient. What can change are the functions that you use it with. So f of x is the part that will change. So some people like to think of this as being, like several steps. The first step being, find f of x plus h. And then you do that. And the next step is to take that result and subtract from it f of x. That'd be step 2. And then your third step is you would take all of that and then divide by h, that being your third step. Okay. If it's a relatively short function, I'll just do it all at one time. But again, if you're struggling with these, or if you've seen it done a different way, breaking it into pieces, that's perfectly fine. So f of x plus h. So when I want to find f of x plus h, remember we go over here, and wherever we're seeking x, we're going to plug in x plus h. So I will have x plus h squared plus 9 times x plus h minus 2. So all of that is f of x plus h. Okay, now let's do minus f of x. So minus, what was f of x? Well, all of that is f of x. X squared plus 9x minus 2. And then the last thing I need to do is divide by h. So all of this divided by h. Okay. From here, it's a matter of simplifying. So I'm going to, FOIL, I'm going to distribute, combine like terms, reduce a fraction. Those are the steps I'm going to have to take. So remember with the x plus h squared, you have to FOIL this. So if it helps you, write it down twice, multiply it out. So I get x squared plus xh plus xh plus h squared. Now distributing the 9, so I have plus 9x plus 9h minus 2. And then here I'm going to distribute the negative sign. So minus x squared minus 9x plus 2. All of this over h. Now I'm going to combine like terms. So notice that my x squared and my minus x squared cancel each other out. I have x squared plus x squared, these two right here, so that gives me 2xh. I have an h squared, so plus an h squared. Let's see, my 9x and 9x over here will cancel each other out. And so I have a plus, let's see, so I got that one. We have a plus 9h. And then my negative 2 and positive 2 over here cancel each other out. So we have 2xh plus h squared plus 9h all over h. Okay, we're almost done. Now I got to worry about my fraction. Notice that I do have an h in common to all terms, so I can factor that out and cancel it. Now you can mentally factor it out, or I'm going to write it down here. So I take out the h from the numerator, I get 2x plus h plus 9 all over h. Then I can cancel out the h's. And so we are left with 2x plus h plus 9. And there is my simplified difference quotient. Number 29, we're asked to use the given conditions to write the equation for the line in the point-slope form. Okay, so I want to write the equation of a line that passes through 2 points. So first I'd start off with what is the point-slope form. All right, so that is y minus y1 is equal to the slope times x minus x1. And x1 and y1 are the coordinates of an ordered pair that the line passes through, and m is the slope. So those are the 3 places where you have to substitute in values. You have to find numbers. Now we have 2 ordered pairs here, so you can use either one. And then how about my slope? How am I going to find my slope? I said, well, we know that slope, we have a couple different ways, but if you're given 2 points, then the value of the slope is going to be the change in the y's over the change in the x's. So y2 minus y1 over x2 minus x1. And it doesn't matter which is your first ordered pair and which one is your second. You just need to make sure that you're consistent. So if this is my x1, this has to be my y1. And this will be my x2, and that'll be the y2. So for this one here, then my slope is equal to, so I'm going to go negative 8 minus a negative 3, so plus 3. All over a negative 3 minus a negative 5, so plus 5. And now simplifying these here, I'll have a negative 5 over 2. So my slope is going to be a negative 5/2. Okay, so now I'll come back over here, plug it into my equation, and I'm going to do it both ways. So I have y minus, using my first order pair, so y minus a negative 3, so y plus 3, is equal to my slope, which we just computed. So negative 5/2 times x minus, and then my first x is negative 5, so x plus 5. So that's one possible solution. Since you have 2 points, you could write it, using the other order pair. So again, same thing. So I have y minus a negative 1, so y plus 8 is equal to my slope, negative 5/2, times x minus x1, so x plus 3. And so either of these two solutions would be correct. One thing to note, if you are writing your answer in the slope-intercept form or as a linear function, then there'll be a unique solution. Number 30, again, we're asked to write the equation of a line. This time we're going to write our answer in the slope-intercept form. And we're given the slope, and we're also given an ordered pair it passes through. There's more than one way to solve this one, but I'm going to go ahead and start with the point slope form again. Y minus y1 is equal to the slope times x minus x1. And remember that we need to plug in values for y1, m, and x1. But we already know all these. See, my x1 and my y1 are the coordinates of the ordered pair, and then we were just given the slope. So if I plug these in, I have y minus 4 is equal to my slope times x minus a negative 6, so x plus 6. So there's the equation in the point slope form. Now I can go ahead and write it in the slope-intercept form. And just to recall that the slope-intercept form is y equals mx plus b. So if I'm going to write it in this form, I need to solve for y. Okay, so coming back over here, solving this for y, remember that we want to multiply before we add or subtract, so I'm going to distribute the 2 on the right. So y minus 4 is equal to 2x plus 12, and then adding 4 to both sides, we'll have y equals 2x plus 16. And now I have my answer written in the slope-intercept form. Number 34, we're asked to graph. In this class, we're going to have several different shapes, so it's really important that initially you analyze the function or the relation and determine what the general shape is. So here, since I have y to the first power and x to the first power, this is, a linear equation. My graph is going to be a line, straight line. When you're graphing a straight line, I just need to know 2 points. So you can either give me a table, or you can go ahead and use the slope to graph your line. I'll go ahead and I'll work it out both ways. So if you want to graph using the table, you get to choose any points you want. There are infinitely many. So pick ones that are going to be easy for you. If I let x equal 0, so again, I'm plugging this into, y equals 3/5 x plus 2. So if I plug in a 0 in here, that all goes away and I just have y equals 2. I don't even have to write that down. I can do that in my head. What's going to be another easy point? It's set up with y equals something times x plus 2. So you really want to substitute in values for x and solve it for y. Now I can use x equals a 1 or a 2, any of those, but the easy choice is going to be something that helps me avoid the fractions. So what if I go ahead and I use x equals a 5? So then I have y equals 3/2 times 5 plus 2. See, the fractions wipe each other out. And I just have 3 plus 2, which is 5. Those are 2 nice points. So here are my 2 points. I've got 0, 2, and then I have the point 5, 5. So 1, 2, 3, 4, 5 on the x-axis. And then 1, 2, 3, 4, 5 on the y-axis. So I've got the point 5, 5. And then our line is going to go through those 2 points. If you prefer, so that's using the table. If you prefer, you can use your slope and y-intercept to graph. So again, we have the equation 3/2 x plus 2. So one point is going to be the y-intercept. We know it's going to go through the point 0, 2. For my second point, I can use the slope. My slope is going to be 3/5. Remember, that's rise over run. So my rise is 3, so I'm going to go up 3, and my run is positive, so to the right, 5. So starting at a point I know to already be on the line. So starting at my y-intercept, I can go up 3, and then to the right, 5. And I have this point here, and then I draw my line through them. Okay. I could also go, down 3 and left 5, because that'd be like a -3/-5, which is positive. So 3/5. So it's not the only way to do it. But either way you choose, you should get the same line. And I do want to see 2 points, or like I said, you may go ahead and use the slope to get your second point.